The last thing I want to talk about in this section is least common multiple. So let's suppose that A and B are natural numbers. Then there is a smallest positive common multiple of A and B. And we're going to call that the least common multiple of A and B, which we write LCM of A and B. So for example, the least common multiple of 3 and 5 is 15, right? Because 3 and 5 are both prime, those are the only factors they have in common. The least common multiple of 3 and 6 is 6. The way we used to find least common multiple was we'd write all the factors of 3 and all the factors of 6, and I would take one from each column, multiply them together, and I'd have a least common multiple of 6. So for the least common multiple of 6 and 14, I factor 6 into a 2 and a 3, and I factor 14 into a 2 and a 7. So the least common multiple would be 2 times 3 times 7, which is 42. Okay, this is great when we're working with small numbers, but what if we're working with really big numbers? If we're working with really big numbers, we need another way to find the least common multiple. Friendly reminder that if two numbers are relatively prime, so their GCD is 1, then the least common multiple is just going to be them multiplied together, because that means they have no factors in common. Theorem 3.15 tells us this. If I have A and B that are natural numbers, then the least common multiple is the product of A and B divided by the GCD. This can be really useful, right? When we're trying to figure out the least common multiple. We don't have a method to determine the least common multiple, but especially for really big numbers, right? That would take a long time. But we do have a quick method to find the GCD by the Euclidean algorithm. So let's find the LCM of 84 and 24, given that the GCD is 12. This is something that we solved for earlier. So I want to find the LCM of 84 and 24. So what I'm going to do is I'm going to take A times B, so 84 times 24, over my GCD of 84 and 24. That's going to give me 2016 over 12, which is 164. So the least common multiple of 84 and 24 is 164. Next, let's find the GCD of 6 and 14, given that the least common multiple of 6 and 14 is 42. So I have the least common multiple of 6 and 14 equals 6 over 14, 6 times 14, divided by the GCD of 6 and 14. Well, now I have that 42 equals 84 divided by the GCD of 6 and 14 that I don't know, right? I can go ahead and multiply both sides by the GCD of 6 and 14. Remember, it's just a number. That's going to give me 42 times the GCD of 6 and 14 equals 84. If I divide both sides by 42, I will find that the GCD of 6 and 14 equals 2. We divided by 42, not 12. Why did I write that funny? All right, so here are our worked out examples. Our homework, for homework, I want you to do problems 3, which is where you're going to find the GCD using the Euclidean algorithm. Problem 4, which is about least common multiples. Next, for problem 5, you got to figure out when some things are relatively prime. Number 6, 12, and 14A and B, I want you to do just parts A and B. If you want to do the other ones, I'd be happy to correct those for you. But those are more proof-based, right? This is a proof-based course, so I really want you to be using your proof-based thinking skills.